finally do law of cosines. Okay, so we got the law of sines. Most of you guys seem decently comfortable with law of sines. There's just a couple of details you kind of forgot or weren't sure how to handle. But I think overall we all have the law of sines pretty well, which is nice because the law of sines is something really solid to kind of like hold on to. A lot of the trig identities is very like, oh. Law of sines is very, you can hold the damn thing. You can do something with it directly. Okay. So law of cosines. I'm going to not do the complete derivation, just to save some time. But I am going to do the beginning, and then I'll show you what the result is. So if I have a triangle that is not a right triangle, let me see. Let me do one freaky one like this. I didn't mean for that to not be straight. What we'll do there. You guys agree that's not a right triangle. So let's call this C. We'll call this one B. Why not? And this one's A. So then this is little c, this is little b, this is little a. Okay. You'll notice something. Do you remember that beautiful giant mess of a bunch of triangles where we proved the sum and difference formulas? Do you guys remember that at all? It was this huge thing, and I had multiple stuff that I was putting on the overhead, and we were getting cosine alpha, sine beta, and shit all over. Remember that? No? If you don't, okay. But the main thing with that was we were trying to find our right triangles that lived in this thing. Now this doesn't look like there's a right triangle that lives in this. I need a right triangle that still uses the same sides of this. So what I do is this. That's fascinating. Okay, so we'll say that this whole thing, let me go ahead and say that this whole thing, how long is this new kind of triangle? We'll say it's x. Kind of makes sense. Because it's the x-axis. Can anyone tell me how long this is here? Anybody? X over 2. Well, you don't know that it's cut in half. If x was 10 and a is 5, that's a bad choice. If x is 10 and a is 3, how long is this? 7. What did you just do? Didn't you just do 10 minus 3?
Oh,
X minus 8. Yeah, it's the whole thing minus this much. And of course that leaves you with that much. Okay. I like it. So let's see what we can kind of set up here. Let's see, how do I want to say this? Yeah, okay. So for this triangle here, let's call this Y. Let's call this Y. This triangle here, how do the sides relate? What relates to the side? What kind of triangle is this? Right triangle. How do the sides relate? Old Greek dude, right? Old Greek dude comes in and says, I got you. If it's a right triangle, what comes in? What can be used? Pythagorean theorem. I love it. Let me stop for a minute. Are you guys doing okay? Have I done anything really strange up here? Do you guys understand? I can do this all day long. I didn't change the triangle, did I? Is the triangle that was given to me still there? Yes, it is. I just decided, I want to look at this weird right triangle that I make there. Why not? So, okay. What's the Pythagorean theorem say? This side squared plus y squared equals careful. You got to stay in the same triangle. Equals b squared, right? Isn't that this length of that triangle's hypotenuse, right? So you just have to be sure you're looking at the triangle you're working with, right? Can I write something for the entire triangle? This whole thing. Can I write something for this entire triangle? Yes, sir. X squared plus y squared equals c squared. Cool. So what is y squared then? Do you see how I have it here? What is y squared? C squared minus x squared. I love it. So let's put that in there. So let's see, I get x minus a squared plus y squared. So I've got this. This is from the little right triangle. This is from the big. So this is little. This is big. Right? And isn't y the same side in both of them? So I know that y squared is this, so I can replace it here. If I wanted to. Okay. What else can I say here? Let's see. Can I use some trig in this big ass triangle here? How can I use angle B in a few different ways? What is the cosine of B in the big ass triangle? I can't use the purple triangle, can I? It's not a right triangle, right? What's the cosine of this? Yeah, x over c. So then what's x? Is everybody cool with that? Cosine of beta is going to be the x side over the hypotenuse, yes? I said beta, I meant b. I like it. So what's x? Yes, so I'll put c times cosine b. All right, so let's do something here. Let's see. So let me FOIL this out. I'm going a little further than I wanted to, but I think that's all right. Do you see how the x squares cancel? Right? The x squares here cancel. And what is x? C cosine b, I like it. So this will be a squared plus c squared minus 2a, and then x is c cosine b. Crazy shit.
Where did you FOIL?
Say again?
What did you FOIL? Get x squared.
This here. Right? X minus a squared. So x minus a times x minus a. And of course, I'm just now realizing this would have been, if I would have changed the a, b, and c around, I would have gotten a squared plus b squared minus 2ab cosine c equals c squared. That would have been a little more dramatic, but too bad for me. Do you notice? I really want everybody to see. If I would have called C, if I would have called it B, if I would have just called it B from the beginning, there would be a B here, right? There would be a B here, right? And of course, the B and the C would have changed. Okay. Do you see how if you cover this term, don't you get a squared plus b squared equals c squared? So let me put this up here. For a right triangle, a squared plus b squared equals c squared. For a non-right triangle, a squared plus b squared doesn't equal c squared. You have to adjust it because C won't be right. If angle C was 90 degrees, what is cosine of 90 degrees? Cosine of 90? 0. Don't you get the normal Pythagorean theorem? So what I really want you to understand, the a squared plus b squared equals c squared that you use all the time is a special case. The actual full rule works for every triangle everywhere. And that's this guy. If this angle is not 90 degrees, I can still relate the sides using this. I just have to adjust my normal a squared plus b squared. I got to adjust it a little bit. Maybe. Okay, so let me try something here. All right, let me leave all this up there. So I went way further, but it wasn't that bad. It wasn't too long. Cool. Let me show you a little something. Something I've never done before. This will be neat. If I put 3 there and 4 there, what's this? You guys should know by now. For a right triangle. 3, 4, 5. Right? Because 9 plus 16 is 25, which is 5 squared. Okay, maybe you should have seen this enough. We've talked about it sometimes. What if I had 3, 4, but this is 92 degrees? Let's make some predictions about what's going to happen here. Do you think this side should be 5 still? Should it be a little bigger or a little smaller? Should be bigger. Could I use law of sines to figure out this side? No, why not? No. What's law of sines for? I love you. Yeah, when you have a triangle, it's not right. Somehow the triangle is wrong, is off. So it doesn't have a right angle. That's what law of sines is for, yes? Okay, maybe. If I had a right triangle, I would just use straight trig and Pythagorean theorem. I've got stuff for right triangles. We got right triangles solved. Ain't no right triangle going to give me any problems anywhere in the universe. If it's not a right triangle, oh shit! So we made law of sines. Law of sines works no matter if it's right or not. But it doesn't work in every situation. Why can I not use, and most of you guys got this answer right on the test. What's missing for me to use law of sines? Can you make a complete ratio? Do you have an angle and its side? Nope. So law of sines can't do shit here. So this guy follows this rule. But to be really honest, it actually follows. Wait, are you gonna work? You look new. You gonna work? Let's go back. This guy, the rule that actually works for everything is this. Why does that guy, why does it look like that? Because what is angle C here? 90 degrees. And what is cosine of 90? 0. So this term goes away. But what is it going to be now? So let's just, it doesn't matter what A and B are. You guys see that? So let's call this A and this B. What angle is this? C. So let's plug stuff in. And what prediction have we made? Did I actually get you guys to predict? Will this be bigger or smaller than 5? Slightly bigger because the mouth opens a little more, yes? 92 degrees? Okay. So it should be a little bit more than 5, the answer we get. So let's put stuff in. So let's see, a squared plus b squared minus 2 times a times b times cosine of the angle equals c squared. Now let's all do this together. Yeah, that's right. If you have your calculator, you can help me out. My blue one is somewhere. Make sure you're in degrees. By the way, a little side note, 9 plus 16 is 25, yes? What are you guys getting? Anybody got it yet? What do you guys get just for this side? Anybody? 25 point. 837, blah, 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 right? Okay, I like it. So wait a minute, real quick, wait a minute. What the shit? Isn't this 25?
Mm-hmm.
Aren't I subtracting something? So how do you get bigger? You can do it, you can do it. What quadrant are we in here? What's cosine of the second quadrant? It's negative. So it's minus a negative, so it adds. Okay, small little detail. Do you have to do that with every problem? No, you never have to do what I just did. Right? But I want you should be, as you're working, you should go, does this make sense, what I got? And part of your brain should say, wait a minute, that should be smaller than 25. But no, it's okay, because that's negative, so you actually add that piece. So then what's C? Just square root what you got. And I get 5.083, blah, blah, blah. Does that match with our prediction? Yes, it's a little bit bigger than 5. So the thing I want you to realize, bless you, the thing I want you to realize about basically any rule like this, so here's law of cosines. So you have this one I just wrote, but they don't have to label. In fact, if I have a non-right triangle, how do you normally determine which side is C? The side that's across from the...
Largest angle?
Not the largest angle. How do you normally determine C? The side that's across from the right angle. If I have a triangle that is not a right angle, which side do you call C? Huh? Any of them. Yes. So it could either be this, or it could be this. Or it could be this. I want you to notice similarities here. So I'm going to be given the most common usage of law of cosines is I'm given two sides and an angle. They could give me A and B and give me angle C. Or they could give me A and C and give me angle B. They could give me B and C and give me angles. Which one? Oh, Jack, you silly boy. Thanks, there, sorry. So the way, so watch how this is really, really nice. Whatever these two are, they're there also. Do you see that? Whatever these two are, they're there also. Whatever these two are not is the angle here and the side there. Angle here, side there. Angle here, side there. It's just Pythagorean theorem with a little adjustment. Why is this adjustment here? Because it's not a right triangle. That's where the Pythagorean theorem works, but do you guys realize that this is just a special case of this? Okay. So let me ask you, let's do a problem. It's a little different from this one. So this should be a quick answer as to why this doesn't work for lost signs. If I give you this triangle.
I have a good question.
Yes.
Could you put the C square in front?
Say again.
Could you put the C square in front?
Of course, yeah, of course, yeah. You can turn that around, yeah. Let's say this is 8, this is 7. Let me ask you guys, can anyone see, is there a length this cannot be? Let's say I give you, this is, this angle is something, less than 180, so let's make it 107 degrees. I like it. This is not the problem I wanted to do, but let me see. Is there any length that this can't be? If I give you this, then it's got to be something. So let me take that angle. So that angle is something less than 180. You guys, I want to make, if it was bigger than 180, I can't have a triangle. Okay. Is there any length that last side cannot be?
It can't be 15 or greater.
Say again.
Can't be 15 or greater.
Good. To make this side 15, I actually need 8 and 7 to lie flat, right? I actually need that to happen. Then it's 15, but do I have a triangle? The minute I kind of do this with them, kind of poke it up, poke, and then it goes like this. The minute I do that, this side has to be less than 15. Does that make visual sense? No. Yes? Maybe? No? Yeah, I like it. And of course, if I really put this up there, then this side could be stupid small, yes? Mm-hmm. It just can't be bigger than freaking, it can't be 15 or bigger than 15. Impossible. So give me a number that makes this work. 10. I think I heard 10. Yes. Why would law of sines not work here? No angle. I need to make a complete ratio for law of sines. There's no angle, so I can see right away. Law of sines is not going to work. I like it. So, have I identified any variables yet? In fact, I could just give you this picture. What should you do for yourself? Identify A, B, and C. So what do you want to call A? 8. What's B? 7. So that makes a C. So this is angle C, this is angle B, this is angle A. And the question is going to be, solve the triangle. If I ever ask you solve the triangle, that just means get all the sides and all the angles. Well, I got all the sides. I don't have a single one of the frickin' angles. How the shit am I going to do that? Well, pick one of the... So I know law of sines does not work. That means law cosines must work. As long as they give me enough information, right? So pick one of the 3. Somebody just pick one of the 3 law cosines equations. Pick any one you want. Okay, so A squared plus C squared? If I put in everything I know into this equation, what's the only thing I don't know? Yeah, I don't know big B. Don't know capital B, right? Go ahead and try to plug stuff in and solve this. So there's a few places you can make simple mistakes. Okay. So let's see. So 8 squared, so that's 64. 7 squared, 10 squared, so that's 100. Twice 8 times 10. Cosine B equals 49, right? Is that cool? Okay. So I get 164 minus twice 8, 16 times 10 is 160. The biggest mistake I see is one of the most basic algebra things, but it's really easy to make this mistake. I see somebody do this. That is wrong. That is wrong. What mistake did they make? Why is that wrong? Is it 164 minus 164, Jeff? You're like, yeah, but is that what that says? What did I do wrong? Say again, sorry?
It's 160 times cosine.
Yeah, it's 160 times cosine B. Are these like terms?
No.
I have 164 minus 160 cosine B's. It's not like terms. All right, so what's the correct next step then? Nope, I can't do that yet. I got to get cosine by itself so I can attack it, right? There's a lot of shit in the way. So let me do the next step. Is that 115?
Yeah.
Thank you. Right? Do you guys see that? That's the easiest mistake to make, and I don't really blame you. I mean, that's a very simple mistake, but it's really easy to understand because the brain just says, "Oh, that's 4. Sweet!" Right? We're just so happy to see something easy in this weird trig thing. But you can't do that. We know we can't do that, but it's really easy just to do it because it's just sitting right there. The negatives cancel, right? And then I divide by 160. So what's the last thing I do? Oops, kind of give it away there. Now you do what? What you wanted to do earlier, right? Let me put it up here. What do I do to both sides? Inverse cosine. And then you throw that in the old calculator. What kicks ass about law of cosines? Does anyone remember the range for inverse cosine? Oh shit. 0 to pi. Sine sucks because it gives us from negative 99, it could be a reference angle. What angles could live in a triangle? Anywhere from 0 to 180 pi, right? So there will never be a possibility of 2 triangles with law of cosines. This still means cosine is a jerk because he took the easy thing and said sine, you could have the weird shit. Right? So I'm still trying to make my cosines and asshole thing work. What do I get here? Can anyone do that for me? Inverse cosine of 115 over 160? Say it. 44?
Yeah,
44.04 stuff? Okay. So I'll tell you what to round to, so you don't go crazy, write all the decimals down. Let's see, does that make sense? That's a relatively small angle, yes?
Yeah.
And what's the smallest side? B.
Yeah.
So that makes sense. So far, right? If I would have gotten 110 degrees here, I know I'm wrong. Because there's no way the smallest side can be across from 110 degrees. That would be the biggest angle. Yes? Say again? What if you get something smaller than... Oh, what if one of your other angles is smaller? You made a mistake. Yeah, there's no question. either you made a mistake here, or you make a mistake
Okay.
on whatever you did.
Alright,
Now, how do I finish this? Am I done?
no, let me do all sign that.
Can I use law of cosines again?
No.
Of course I can.
Yeah.
I just used two different signs.
Yeah.
Do I have to use law of cosines?
No.
What can I use instead?
All sign.
Law of sines, because now what do I have?
And then you go to
A
sign.
complete ratio, right? So let's do this, and then I'll move on. Let's figure out angle C using law of sines, and then we'll figure out angle C using law of cosines. And they better come out the same, or else we can throw out all this stuff. And just forget about this section. Okay. I'm gonna erase this. So let's do law of cosines first. So if I want to figure out angle C, that means this will be C. That means the easiest way to make this work is to make this B instead. There. So it's always, whatever these two are here. This is the other angle, and this is the other side. All right, so real quick, I'm going to go this a little quickly because we just did the full thing. So it's going to work the exact same way. 64 plus 49 minus twice 8 times 7 cosine C equals 100. I get 113 minus, what is this, 112? I believe. Yes, okay. Same stuff, right? The exact same steps, just different numbers showing up. Subtract. The negatives cancel out. I get C is the inverse cosine of 13 over 112. This should be the biggest angle in the triangle.
Okay, 83.
83?
Yeah.
Point, whatever? Okay.
Yeah, 83.33.
Okay. Is everybody with that? So that makes sense, because if that was 83, that's 44, that's 127. So the last side angle would be 53, or roughly, right? To make 180. Are you guys with me? The minute I got two angles, I got all three. Let's try law of sines. It's got to come out the same. So if I want to figure out angle C, but I want to do it with law of sines, oh shit. No, okay. How would I set that up? Law of sines. Law of cosines is LoCo. I guess I could call this loci. Sure. Law of sines. LoCo and loci. Say again? Angle C, same angle we found here, just to see if I get the same answer. So what's the complete ratio I can make? Sine of 44.04 divided by 7, and now I want C. Yeah. So I get sine C equals 10 sine 44.04 divided by 7. So again, angle C is inverse sine of this mess. I can plug all that shit in the calculator at one time. I try to plug as much as I can at one time in the calculator so I don't have to write all the decimals and all that shit for every step.
I get 83.25.
Ah. Why is that a little different? This was 83.3, right?
Yeah, 83.33.
Can anyone see? It's basically the same thing, correct?
Mhm.
Any human would say, any human I've heard, would say these are basically the same number. They're both frickin' 83.3 if they're rounded.
Yeah.
Why are they a little different?
Angle C?
Yes. What is this actually what angle C is? What did I do with angle C's number we got? I rounded it. So of course if I use a rounded number, I'm gonna get a number that's not quite right. Okay, maybe. One reason you might not want to use law of sines is because when you take an inverse sine, it could give you a reference angle. Law of cosines will never do that. It will just give you the angle it is. It'll never lie to you. Okay, maybe. Okay, maybe. Same thing we got, both ways, 11. Okay, so that's law of cosines, and I have both of those. So those are just adjustments to make trig work directly with non-right triangles. Okay, that's what each of those things are. Okay. So let me ask you this. If I, oops, let me get that up there for a minute. Let's do something a little weird. If I gave you a triangle, it's got angle x, y, and z, so side x, side z, side y. And I want to know angle z using law of cosines. How would you set up the formula? Yeah, so in general, it's a squared plus b squared minus 2ab plus sine c equals c squared. So the important thing is these are here. This angle and this side are the same pairing. So if I want to know angle z, that means I want a z here. Yes? Which means what's here? Which means what's here? XY. Which means what's here and here? All right, so who gives a shit if it's A, B, C, X, Y, Z, W, H, G, and N? Right? Okay, maybe. Okay. Okay. So that's law of cosines. Now, the next two sections talk about, well, let's say the next 4 sections talk about alternatives to the XY plane. What's the purpose? I love you guys. I just know some of you guys are like to torture me. But what's the purpose of the XY plane? What's another way we use the XY plane idea in real life? Say again? Oh, okay, so I can graph a bunch of shit. Sure. I love it. So I can graph a bunch of shit. If I give you 2, -3, what does that enable you to do? What can you do with that? I can locate that point. I can find it, yes? So it's just, the standard example is latitude, longitude.
Yeah.
If you're in a boat and you're like, we need help, and I'm like, well, where are you? And you're like, I'm in the ocean. No. Tell me your latitude, longitude, because then I can find you on the grid that we put on the surface of the earth, right? And flat earthers are like, say it's a grid. No, shut up, guys. It's curved during the other. All right, sorry. Everybody with me? So that's your standard real life thing about XY plane is latitude, longitude. Makes sense. If you like astronomy, it's right ascension and declination. That's sort of like, instead of a grid on the earth, it's a grid we put on the sky to find stars and such. You guys semi with me? Okay. So, did I tell you real quick, did I tell you the urban legend behind where the XY plane came from?
No.
I did? Yeah, there you go. All right, thank you, Christian. It was when Descartes
There was a mathematician called whose name was Descartes, René Descartes, right? And he was sick at one point. He was laying in bed, just like staring at a ceiling, going, "Please, God, let this be over." And he saw a fly walking around on the ceiling, and he's like, I could find that fly by going this way and that way. And he created the XY plane. That's the urban legend, right? And that's why we also call the XY plane, we call it the Cartesian plane, after Descartes. I don't know if you guys ever heard the word Cartesian plane.
No.
No? Well, not yet. Right? Sort of sounds like a Greek mythical place. Come to the Cartesian plane. No, but that's another name for the XY plane. Okay. I love this idea. This is, I still remember the first time I learned about this. So to locate a point, like right there, to locate that point, I can tell somebody how many blocks to go over and how many blocks to go up, right? And then I say like that. So if I lived in Salt Lake City, for example, has anybody ever been to Salt Lake City? I had a friend who lived in Utah and went to Salt Lake City, and it is just so freaking grid-like. It actually sort of messes with your mind. Because I come from Virginia Beach, where a road can intersect itself. So I live at the intersection of Elm and Elm, right? And then you go to Salt Lake City, it's like, everything's like perfect. It's like, holy shit, it's just weird to me, sorry. So if I lived there, I could tell somebody, yeah, you go 7 blocks east and 5 blocks north, right? South would be negative. West would be negative. Are you guys with me? Okay, so I can identify where I am using a point. That is not good if I have something moving in a circle. If I have something moving in circles, there's much better ways to identify a point on that circle. So I can find that same point, but instead of telling somebody how much over and how much up to go, I could instead say, all right, you're here, looking straight ahead. Turn by this angle and then walk this far. If I tell them to turn by this angle and then walk this far, won't they still get to that point? I didn't give them X. I didn't give them Y. I said, turn by this angle and then walk by this much, right?
Trespassing.
Say again, sorry?
Trespassing.
Trespassing? What?
You got a hot fence to get to yourself.
Sorry?
I was saying you got a hot fence to get to yourself.
Oh, it's true. It's true. That's a good point. So don't try that in Utah there. Yeah. They won't take kindly. All right. So let's say this is a point in the ocean, right? So in fact, this is very often, how do you navigate? Even if you've never been in a boat, I'm almost certain you've seen something. How do you navigate in a boat? Say again? Okay, sure. And what's a compass tell you? Direction, but doesn't it tell you angles? So in a boat, you talk about a heading. Turn to this heading and go for 7 miles. Isn't that turn by an angle and go this far? Isn't that angle distance, not XY? Okay, so this is what's called, let me see you guys, does it make sense to call this the rectangular coordinate system? Because I can very easily define a rectangle, right? There, I just defined a rectangle. X, Y, bam, I have a rectangle. So it's good for problems that involve rectangular or square kind of things. Not everything follows that. What works better for circular things is called polar coordinates. I gotta start putting you guys. You're dead, you're dead. Okay. Polar coordinates, not surprisingly, this is theta. And also not surprisingly, the distance I go is r. So in polar coordinates, I would tell somebody r theta. Personally, you're going to see why I wish we had turned these around. I have no idea why r comes first. It just does. Because if I have somebody, I'm going to tell them how to turn and then to walk. If I tell them how far to walk and then tell them how far to turn, that doesn't help. Anyway, we're just going to deal with that. Now, help me out, guys. Is there a relationship? Do you guys all agree, no matter where I put a point, I can obviously find it with x, that'll be negative, y. But I can also find it with theta and r, right? Do you guys all agree with me? There's no point on the xy plane that I can't find by also using theta and r. Do you guys all agree with me? It's okay if you don't. You know, you're insane. All you math people are insane. Okay, all right. Is there a relationship between x, y, and r and theta? You take this guy away for now.
Yes.
Of course there is, right? There's really fundamental relationships, yes? All right, what are they? What is x in terms of r and theta? We can do it. What trig function would I use to relate these sides?
X is cosine.
Sure. Okay, so help me out. What's cosine theta from this little triangle? Richard? X over r. So x is r cosine theta. So if somebody told me, turn this angle and then walk this much, and I'm like, I don't like polar. I like freaking rectangular, you crazy person. Well, I can take what they told me and get what x is. Right? If somebody said, you turn this angle and walk through all the yards to get to my house, and you're like, I don't feel like getting arrested today. You can just take the information they gave you and turn it into an x. All right, well, how do you get the y piece? What do you think? What trig function relates this to what I know?
Sine theta.
Sine, yeah. So this will be the same way this was. This will be y equals r sine theta. There are some other relationships. What else that I have not used yet that relates x, y, r, and theta? There are two more. There's the most basic one. What kind of triangle is that? Right triangles. How do x, y, and r relate? Yes, x squared plus y squared minus 2xy. No, because it's a right triangle, right? Equals r squared. Now here's the one that's really simple to forget, but what relates the angle directly to x and y? What trig function relates this angle with these sides? Y over x is tangent. So tangent theta. So theta is the inverse tangent of y over x. Okay, I like it. All right, so I do have a handout. I want you to realize something. I kind of said it this way. I want you to realize something. Both of these are ways to convert from one system to the other. Right? If I have polar, I can use these to convert back to rectangular, yes? If I have rectangular, I can use these to convert back to r and theta. Do you guys see that? It's just like converting feet to inches. It's just a little more complicated because of course it is, right? It's freaking weird ass x, y, and r theta. So, let me give you this, and you're going to try some of these. Who might be in there? Thank you. Sure. Any- right, guys. So I collected everything we just talked about up here. Right? There they are. Okay, so these are conversion formulas. So if I know r and theta, I can figure out what x and y would be, and vice versa. So let's try this first one together. So it says convert to rectangular coordinates. So this is currently polar, that very first thing. So can anyone tell me what r is? 2. And what's theta? 5 pi over 3. I love it. So what's x going to be? How would I get x? I want to convert to rectangular, which means xy. Yeah, x is r cosine theta, so it'll be 2 cosine 5 pi over 3. Anyone know what cosine of 5 pi over 3 is? What quadrant is that in? Well, it's just shy of 6 pi over 3, which is 2 pi. So what quadrant is it in? Fourth quadrant. It's just shy of 2 pi, so it's fourth quadrant. Reference angle is pi over 3, 60 degrees. What's the cosine of 60? A half, and that's in the fourth quadrant, which means it's positive. So this will be twice 1/2, which is 1. And what's y going to be? Two sine 5 pi over 3. Oops. And what is sine of 5 pi over 3? Well, we're in the fourth quadrant, right? So it's going to be negative. 5 pi over 3, 60 degree reference angle. If cosine was 1/2, sine has to be the bigger one. Root 3 over 2. It's negative, because I'm in the fourth quadrant. So that is negative root 3. So this is the same thing as 1 comma negative root 3. So real quick, let me do this a little out of order. I'm going to add something to the second part down here because it's not a bad idea just to do this. So I'm going to do, I'm going to create a letter before A. I'm going to call it, what do you got, Jeff? I'm going to call it this. All right, doesn't matter. So, before it, so I'm going to graph this point, 2, 5 pi over 3. Let's graph this. And this is what polar coordinate paper looks like. So on Canvas, I'm going to post some blank polar graph paper, basically this, so that you're able to do the homework easier. So you don't have to go buy polar graph paper. You can if you want to, or you can find it online if you want to, print it out, whatever you got to do. So this is new, but it's not difficult. It's just new. So remember what I said. How do I tell somebody how to get to a point? I tell them what angle to move through first, right? So what angle for that point am I going to be facing? 5 pi over 3. And do you see where that is? So it's down here, right? 5 pi over 3. What just happened? I'm zooming in. Oh no, shit. Okay. All right, this poor little dude. There we go. Okay, so face 5 pi over 3. Look at 5 pi over 3. And then go out 2. Now, do you notice? I don't have x, y. I have r theta. Do you notice how r are these circles? So this is 1. This is a radius of 1. This is a radius of 2. This is a radius of 3. Do you guys see that? So I don't have x, y. I have a scale. The theta scale is easy. It's the same old theta scale we use forever. And the r scale is also the same one we've used forever, but it's circles, right? If I go a radius, it's going to create a circle. So I want to face 5 pi over 3, and I want to go out 2 steps. Is that the right one? Yes. I'm too close to this thing. So I want to face 5 pi over 3. I'm going to go 1, 2 steps out. So there it is. Now, real quick, can you guys still see the XY plane here?
Yes.
Right? Here's the y-axis. Here's the x-axis. Doesn't that look like 1? Isn't this 1? 1. And then this would be negative square root of 3, believe it or not. I really want that. I can't tell exactly because they don't have good enough scale. But do you all agree with me that's definitely positive x, negative y to get to that point? And in fact, it looks like 1, and it looks like a little less than 2. So that's 1 negative square root of 3. That's how I get to that point. And isn't that exactly what? So that does show that that makes sense. The rectangular point, 1 negative rad 3, leads you to the same place as the polar point, 2 comma 5 pi root. Okay, maybe. Okay, I'm not going to do all these because they're based. So, like for part B, let's figure out the x piece. How would you figure out the x piece? That would be what's r? Negative 12. Let me see. How do I turn down? This will turn it off. I don't know. Okay, well, too bad for me. Yeah, negative 12 times cosine 7 pi over 6. Yeah, what's the reference angle for 7 pi over 6? 30 degrees, pi over 6, right? Yeah, it's 210 degrees, but what's the reference angle? 30 degrees. That's close to the x-axis, so what's cosine? Is it small or big? Should be big, rad 3 over 2, and since that is in the third quadrant, it should be negative. So this will be negative 12 times negative rad 3 over 2, so this becomes positive 6 square root of 3. Is that cool? The negatives cancel? And then y, you get it the same way, right? You would just do negative 12 times sine of this. Sine of that is negative 1/2, so you would get y is 6. Now, why is this one hard to graph here? Why is this one? In fact, not just hard, but I've already identified the scale, didn't I? What's the biggest R I can handle given the scale I picked? 1, 2, 3, 4, 5, 6, 7, right? What could I do if I had to make 12 fit on there? Same thing we did with the XY plane. Every step could count as 2. Then it would be 2, 4, 6, 8, 10. 12. I could do it, right? I'm not saying I'm going that way. I forgot what the angle was, but just I've got to get out to the farthest, to the 12th circle. Well, I could just change how big each step is, exactly like we do with XY scale. Huh?
So it just depends.
Just depends, exactly like the XY scale. Yeah.
So if you do 5 steps, you go 5 steps.
Yeah, if I have a Y that's 380, I'm not going to go 1, 2, 3, 4, 5, 6. I'm going to get there. Just keep taping new pieces of paper on the floor. I'm going to get to 360 or whatever it was. No, I'm going to go by 60s or 100 or something. Of course I am. Okay, maybe. Okay. This gets interesting. That's where we're going next, is graphing these, but we're not quite there yet. Right now, I just want to convert these. So anytime I have a situation where I'm given r and theta, there is a way to convert to x and y. So, let me see. I see a sign. Can I open up my eyes? No. I see a sign, so I should expect what letter to show up, what variable, because which variable is related to sign?
Why?
Y. What is supposed to be in front of sign for it to become y? What is y equal to? It's up there. Y equals r sine theta. Is there an r in front of that sine theta?
No.
Nope. What can I do to both sides so that I do get an r in front of that sine theta? I want to just give that side an r, don't I? So what can I do I've got to do something to both. I can't just change one side. If I multiply this side by r, I better also multiply the other side by r. So I get r squared equals 5r sine theta. What's r sine theta? What did we say r sine theta is?
Why over?
Y. And what's r squared? Let me write that better. So x squared plus y squared equals 5y. Is that totally in rectangular coordinates now? Meaning, does it only have x and y in it? Yes. It's got no r, no theta. So if I see like an r cosine theta sitting somewhere, then I could just replace that with x, right? Because that's what x is. Can anyone tell me what this is the equation of?
Sine squared plus cosine squared equals 1.
Nope. You could do it. So if it was x squared plus y squared equals 1, what's that the equation of? X squared plus y squared equals 1. What's that the equation of?
Unit circle.
Unit circle. Kick ass. What if it was x squared plus y squared equals 4? Now it's not a circle of radius 1, it's a circle of radius 2. X squared plus y squared equals r squared is an equation of a circle. Do you see how it's equal to 5y though? If I subtract the 5y over, could I complete the square for the y? So what this is a circle that's been shifted on the y-axis. Because the y would be like y minus 1 squared or something, right? So real quick, right now, I'm kind of mixing everything together, but that's okay. I want you to notice something about your calculators. If I hit y equals right now, it comes up with y equals. Oh, that's crazy. If I hit mode, do you see anything up there related to what we're talking about right now?
Polar.
Say again.
Polar.
Polar. Let me do two things. Let me change it to radians, and let me change it to polar. So now watch what happens when I hit y equals. Hit y equals. Look at that. I have something left over for some time. Now it has r equals. Of course it is, because I don't have x and y in polar. I have r and theta. So what was this equation? It was r equals 5 sine theta, right? Watch what happens when I hit the variable button. That's my all-purpose variable button. So in this case, it's going to be theta. Look at that. And if I hit graph, well, let's see. I might be in a weird. Well, let's see. If I hit, remember, if I hit zoom, everybody hit zoom 6, just to make sure we all have the same thing. Now, real quick, does that look like a circle? Not quite, right? Why? It is a circle, though. It totally is. Is my window a perfect square? No, it's a bit rectangular, right? So everything looks smushed. To be really honest, everything in this graphing calculator looks smushed because it's not a perfect square display. So that is a circle. That's not Stewie's head. That is supposed to be a perfect circle. Okay, maybe. What axis, if I ask you this weird kind of question, what axis is this centered on? What makes it, what axis is this centered on? What would you say? What axis is this kind of like sitting on? Or what's a better way to say this? Where is the center of the circle? On the what axis?
The y-axis.
Y-axis. So I would say this circle is centered on the y-axis. What could I do to the equation to make it centered on the x-axis instead? Which piece of this relates to the y? Which piece of this? Yeah?
Sine.
Sine. So what relates to
Cosine.
relates to cosine? Yeah, cosine relates to x, right? So watch what happens. Oh, it's the same damn circle, just on the x-axis, right? Okay, I like it. Hey, Mikey. So watch what happens if I do this. 5 cosine theta plus 5 sine theta. Okay. Two things happened. Now it's centered diagonally, both in the x and the y, and it's also bigger because I just basically doubled the radius it could get. Okay, maybe? It's got sine and cosine, so it should be parts of both axes, so it should be added diagonal. And if you do stuff like make this 2, then not surprisingly it's not at a diagonal anymore. It's more on the y-axis now because it's less on the x-axis. It's only 2 on the x-axis, 5 on the y. Okay, maybe.
Is this the one where it's like, where if it's even, it's not symmetry, and then if it's odd, it's symmetric?
There are symmetry things to discuss here. Symmetry with polar gets a lot more freaky, right? In fact, let me just do this. Okay, can you see that? Let me do that again. Let me do 2 things. I'm going to blow this up. And I'm going to make it go slower. Don't worry about any of this at the moment. Real quick, do you see how theta minimum is 0? What's theta maximum? 2 pi, right? 3.14 doubled, so 0 to 2 pi. That kind of makes sense. So watch this. It should do this slower now. Let's see. Of course, it's too big, Jeff. But isn't that frickin' sweet? Isn't that silly? I just made the calculator do something that I bet most of you didn't know it could do. And I did it with a relatively simple thing. What am I doing to the cosine of the sine when I put a 5 and a 4 in there? What am I changing? No. What changes when I put a multiplier in front of the angle? Let me say I put a k theta, right? K. K.
The cycle.
All right, the period changes, right? So let me change this to 3. Okay, that definitely looks different, yes? A little bit? I don't know if you guys are with me or not. Yeah. So, I mean, you can play around with this. This is how we eventually can make a butterfly. I don't know if you guys, I think in Canvas I got the butterfly up there, right? So there is a butterfly equation that will make a butterfly with the wings and everything. Maybe. So we'll look at that. I should have looked it up, but that's all right. Okay. So that's how you use your calculator to graph some of this stuff. does anyone have this second dude here, part B? It's a little bit weird. What's the only, I could use this. I really could. But I'd have to understand how to. This doesn't really work directly. So, do you see this equation right there? So if I take the tangent of both sides, what is tangent theta? Y over x. And what's the tangent of pi over 6? Other way around.
Yeah.
Yeah, so it's rad 3 over 3. So I get, if I multiply the x up, what is the equation of? What is that the equation of? Y equals mx. Isn't rad 3 over 3 just a slope? What's that the equation of? I think I heard it. It's just a line, right? Isn't that just a line? And look at this, real quick. Theta equals pi over 6. It's right here, yes? Does the equation say anything about r? So does r have to be something specific? No, it can be whatever it wants to be. So as long as theta is pi over 6, look, as long as theta is pi over 6, r can be whatever it wants to be. Don't I get a straight line? That makes sense. That's why theta equals pi over 6 leads to the equation of a line, because it defines a line. Okay. What time is it? Okay. Now, real quick, look at part C. Do any of our conversions involve secant? No, not directly. What is secant also known as? Yes. So this is r equals, and there are cosines running around. What do you wish was in front of the cosine? And where do you wish the cosine was? It kind of sucks that it's in the bottom, doesn't it? So two things. I wish it wasn't in the bottom, and I wish what was in front of it. How would I replace it with x? What has to be in front of it? R. So can I take care of both of those at once? What do I get if I multiply both sides by cosine?
R cos theta equals 3.
Yeah, so if I multiply both sides by cosine, I get r cosine theta equals 3. And r cosine theta is? X. I get a straight line. Again, but a straight up and down line now. So let me try this. If I put in here, oops. How do I put secant in the calculator? There is no secant button. Well, I just do this, right? So if I put in here 3 divided by cosine theta, there you go. I get a straight line, but I get it. Did you notice what it did? Let me change one thing and then do it again. Let me put this back and watch. What part of the line does it graph first? Okay, that's weird. It didn't just draw a line. It started from the x-axis, then went up, and then it came back down and went back up. Okay, that is weird. And that is because theta starts at 0. So I put 3 divided by cosine 0, that's 3. Right? And then it kind of goes from there. So that's why I kind of started in the middle of that line. Okay. Let me see. Let's just do a couple of these. This is a little bit simpler. These problems here. If I'm given rectangular, so this is xy, and I want to convert to polar, I really just have to do these two things. It's very straightforward.
Both of them?
Say again?
Both of them?
Yes, because
They use both.
if I want a polar point, I need r and I need theta. Yeah. So how would I get r? Well, r squared would equal x squared plus y squared.
2?
Well, square root of 3 squared is
3.
3 plus, 4. So r is 2. I like it. And then theta is the inverse tangent of y over x. Does anyone know what angle that is? We just did it a second ago. Pi over 6 or 30 degrees, yeah. So you're definitely going to want to use radians here. In fact, you almost always want to use radians unless the problem gives us degrees. But do you guys see, so I'm given x, y. Okay, so I just square them, add them, and I get r when I square root. That's direct. If I'm given x and y, that's very direct. If I'm given x and y, I do the ratio and then I do the inverse tangent. So this one, let me ask you, what angle would that be? Can you guys, what angle would lead to rad 2 over 2? 45 degrees. What quadrant am I in? Say again?
The second one.
Second one. X is negative, y is positive. I'm in the second quadrant. So what angle in the second quadrant has a reference angle of 45? 135 or 3 pi over 4, right? So I actually don't even have to do the tangent work. That's going to be a 45 degree angle. In the second quadrant, that's 135, which is actually 3 pi over 4. I don't have to do this work if I just can tell what this shit it is. I know it's going to make a 45 degree angle. Because that's in quadrant 2. How do I get r? Well, I just square both of them, add them together, right? And square root the answer. I just have to do this guy. That's beautiful. Okay. So real quick, last thing I want to do today, and then I'll let us out. We'll look at these next time. Can you guys real quick do A and B for me? Can you graph those two? We've already identified the scale as by ones on the r-axis. All right, so let's see. On part A, where am I facing? So I start at the origin, facing 0, and then I face pi over 3. So I look this way, and I go how many steps? 1, 2, 3. Bam! So that's A. So please, dear God, if the homework problem gives you a lot of points to plot, please label them. Don't just give me the star field of things, and I'm like, oh shit, how am I going to grade this? I don't know which one's supposed to be which one. So B, where am I looking? So I'm facing 3 pi over 2, and I'm going to walk 4 forward. 1, 2, 3, bam. Now, how would I do part E? And then we'll head out. How would I do part E? Where am I definitely facing for part E? 2 pi over 3. So I'm looking this way. But am I going to walk forward? I'm going to walk backwards 3. So I'm going to face 2 pi over 3, and I'm going to walk back 3. 1, 2, 3. So that is E. So R can be negative. It just means back the hell up. That's all it means. Why would that be useful in a boat? Because I might get to dock and have to go backwards to get in the right position, right? Okay, maybe. So, all right. I promise you that was it. I'm not gonna add more stuff. That'll be enough for today. I will tell you this. I decided we're definitely gonna have to make a few more sections of extra credit. The only other section I identified right now for extra credit is gonna be section 10.5. I think that was a new one that I didn't. Did I already make section 10? No, section 10.5 is a new extra credit opportunity. I will talk about it briefly, but you won't have to do the homework. Okay, all right, guys, that's enough. We'll see you tomorrow, unless you come by the Math Study Center.